Hi everybody, this is Dr. Shaner. I'm going to give you a video that's a pre-lab lecture for lab number 9. In this lab you're going to learn how to scale up or down reactions, meaning to do them on a larger scale or a smaller scale, which might be necessary if you run out of one of the components or want to make more of the product. And we're also going to review calculating percent yield. So after you watch this video, go ahead and open up the handout, and there'll be a link to the pre-lab questionnaire. So you'll do that just like you've been doing in the past weeks. And then you'll complete the calculations that are on the handout, and that'll be your report this week. So I'm going to make this video that's going to review how to calculate your percent yield using your reagent table. And then I'll probably make another separate video about how to scale up and down reactions. All right, so watch both of those, and then you can move on to everything else. Okay, so during the last experiment, the reaction was the synthesis of banana oil, and you were introduced to reagent tables. And this can really help you prepare, get ready to come into lab and be ready to set up a reaction because you'll have all the information you need in front of you. So it helps you keep organized. So just to review here, this is a reagent table for the synthesis of banana oil. We have the components that are going to go into our flask. We have our reactants, and then we have an acid that we're including in a small amount. And then the things that we're going to include in our reagent table are the molecular weight, the equivalency, the millimoles of each component, its mass, and if it's a liquid, its density and its volume. And so I've kind of color-coded things here. The things that are in red are molecular weight and our density. These guys are substance specific. All right, they are properties of that substance, right? Not specific to this reaction, but glacial acetic acid has a certain molecular weight, has a certain density, and you can look that up, okay? So those are things that are related to the substance itself. In the procedure for your reaction, you're going to be told about the amounts of the relative amounts of things. So for instance, with the banana oil, you were told the millimole amounts of glacial acetic acid and isopentyl alcohol, and then the volume amount of the concentrated H2SO4. And then you can use the information that you look up about the substance and the information you're given from the procedure to calculate all the other values. Okay. So let's say then that you want to try to figure out, you do the reaction, you want to figure out, did you do a good job or not? You want to know about your percent yield. And so when you do that, what you need to do is you need to figure out how much of the product you could possibly make. So in this case, if we were to use this reagent table to set up our reaction and then actually make our isoamyl acetate, our banana oil, we would want to know, did we get a good yield or a bad yield? So we need to know how much we could possibly make. We need to know our theoretical yield. Okay, so to do this, the first thing we should probably do is write the balanced chemical reaction, okay? The reagent table tells us about what to put in our flask, but it doesn't really tell us about the reaction that's going on. Okay, so you should write your balanced chemical reaction. So in this case, we have our glacial acetic acid plus our isopentyl alcohol. We're going to include a little sulfuric acid. And then we'll get our banana oil, isoamyl acetate. Okay, and in this case, we need to know the stoichiometry. And the reaction here is 1 to 1 to 1. Okay, so 1 glacial acetic acid reacts with 1 isopentyl alcohol to make 1 isoamyl acetate. Okay, and so we need to know that stoichiometry if we want to calculate the theoretical yield. All right, so then when we look at the theoretical yield, if you remember, we need to know, is one of these reactants a limiting reagent? Okay, is it the one that's going to limit how much of this product we can make? And so we can see, we could probably do this without actually doing a calculation, but we'll go through it in either way. So we can see that we're going to react these in a 1-to-1 ratio, okay? But we can see that we have more glacial acetic acid, twice as much as we do isopentyl alcohol. So we can see from this that our isopentyl alcohol is our limiting reagent, okay? So this one's kind of easy to see, but if you weren't sure, what you could do is you could start with or how much of each of your reactants you have and figure out if you use all of that reactant, how much of the product can you make? And then you can see which one's limiting that way. All right, so we can kind of already figure out, we already know which one's limiting in this case, but we could go ahead and try to figure out if we start with our isopentyl alcohol. Let's try to figure out how much of our banana oil we can make with this. There's lots of places we could start with this. I'm just going to start with the mass, just so you can remind yourself about all the calculations. So in our procedure, in our reagent table, we start with 7.05 grams of isopentyl alcohol. All right, we can convert that to moles by dividing by the molar mass. Like I said, there's lots of different ways to do this. Like you can start from different points. All right, then we get to use our reaction stoichiometry. So 1 mole of our isopentyl alcohol, we'll just abbreviate it there, gives you 1 mole of our banana oil, okay? All right, and then we want to go from moles of banana oil to grams of banana oil. So we need to know the molecular weight of our product here. So we can look that up. And then we're going to use that in our calculation to convert from moles of banana oil to grams. So we're going to multiply by our molar mass. And we do all of our calculating across, and we get 10.41 grams. So if all of the isopentyl alcohol is converted to product, that's how much product we would make. All right, so we know that that's how much that's our theoretical yield. But let's just go ahead and just see if we start with our glacial acetic acid, let's see how much of the product we can make. Okay, so we start with 9.61 grams. We're going to divide by our molar mass. We're going to account for the stoichiometry of the reaction. 1 mole of glacial acetic acid gives us 1 mole of our banana oil. We're going to multiply by the molar mass of our banana oil. And if all of the glacial acetic acid was converted to the product, we would be able to produce 20.83 grams. All right. So we can see that we then look at which one is smaller. And we can see that, like we said before, the isopentyl alcohols are limiting reagent. Okay. So our theoretical yield is 10.41 grams. All right, that means that if we run this reaction until we run out of one of our reactants, we could theoretically make 10.41 grams. Oftentimes we don't make that much because maybe your lab partner spills some of your product, or during the process of purifying the product, you lose some of it. And some reactions just don't go to completion. It may not even be your fault. But it's often helpful to figure out what our theoretical yield is, and then we can compare that to what we actually make in the lab. So if in the lab, when you do this experiment, you set everything up according to your reagent table, and then at the end you isolate 7.32 grams of banana oil from the experiment, we can calculate what the percent yield is. So our percent yield is going to be the actual yield, or the experimental yield from the experiment that you actually set up, divided by the theoretical yield that we calculated, times 100. So in this case, we would have our 7.32 grams divided by our 10.41 grams times 100, and we get 70.32%. Okay, so that's our percent yield. All right, so the important things to do here is remember to write your balanced chemical equation so you know the stoichiometry of your reaction. You might notice that the amounts that are given in the reagent table are not always the same, or not often the same as the stoichiometry of the reaction. If you remember back to the banana oil experiment, they said we're going to include extra glacial acetic acid to help this reaction equilibrium go to completion and make more of the product. So we added an excess of the glacial acetic acid to make more of the product. All right, but when you do your theoretical yield calculation, you need to know the stoichiometry of the reaction. Okay, so that's it for this one. In the next video, we'll talk about scaling up and scaling down a reaction.